Okay, so we're going to be running these connections here as active-active and these connections here as active-active. Now, how are we going to do that? Well, the solution is we're going to run LACP between these two Ethernets and another LACP bundle between these two Ethernets to effectively make two lag groups, which is quite extraordinary because, of course, router 1 and router 2 are separate routers, separate PEs. They could be geographically dispersed. However, of course, router 1, router 2, router 3 and router 4 are all going to be making the same learning bridge using EVPN. And of course, we're running over MPLS and IBGP. So let's have a look here. So the first thing we have to do on router 1 is we have to give it the ability to create another aggregated Ethernet, because of course we have one already from a previous example. So we're changing the Ethernet device count to 2. Here we are on the aggregated Ethernet 1. We've got flexible VLAN tagging on, and here's where we're marking our ESI. Here's where we're turning on our LACP, and both the ESI and the LACP system ID really must be the same between router 1 and router 2, because of course they need to know that they're on the same customer. And of course, between router 3 and router 4, again, they need to be the same but different to 1 and 2. And we're going to be using 14 here for 3 and 4. Okay, of course, we're telling the ESI, the segment identifier, that we're all active. We're going to be all active here and all active here. Here, we're letting the aggregate Ethernet know that it's VLAN 800 and that we're using encapsulation VLAN bridge, which is a service provider way of saying that, that we're bridging on this interface and we're VLAN 800. Here, of course, we have the set interface IRB, and we see the way that we're integrating the IP into this particular routing instance. And here we're finishing off the aggregate Ethernet. So down on the routing instance, we're pulling it all together. We're allocating the VLAN ID to the routing instance. We're attaching the IRB interface. Of course, we've got our target. And then under protocols EVPN, we have the interface itself. And then down here, we have really the only two commands that are different between router 1 and router 2 at all, and that's the route distinguisher, because of course they're all going to need the same target. However, here the route distinguisher is going to separate router 1 from router 2. Now, down on router 3 and router 4, again, all of these commands are going to be practically identical. We're going to have a different ESI because, of course, we have a different client router here. We're going to have a different LACP system ID. It really must be different because, of course, we're bridging here at layer 2, and these packets will see each other otherwise. And, of course, we'll need the two different route distinguishers from 3 and 4. The only other thing we have to bear in mind is that in our particular question, we've been asked for router 3 and router 4 to be using VLAN ID 801 and router 1 and router 2 using VLAN ID 800. Now, the normalization of this is actually really quite simple. All that is required is to configure 801 on router 3 and router 4, and then inside the routing instance, type in the 800 and the normalization takes place. And that's EVPN.